So for this question, predict the product and propose a mechanism for its formation, right? You have a ketone and you have an acid and you have a halogen, and there's a big question mark to find the product. And this will be your byproduct, which is also an acid. HBr is also an acid. So you have these options, right? You have option A to D, giving you few seconds to figure out what you think the product is going to be. Okay, now that you've had some time to think about it, let's look at the mechanism, and then we'll come back and then we will choose which will be the appropriate product. Okay, let's do it. It didn't want to stick. Anyway, so over here we have the mechanism, right? We are going to go through it, so don't be in a haste. Okay, I'm going to take you through it step by step. All right, so the mechanism for this reaction is in two parts. Okay, the first part is going to be Enol formation, and the second part is going to be halogenation. Okay, so I'm going to go through it with you guys. Before you create the Enol, or before you form the Enol from the ketone, the first step you have to do is protonation. So protonation means you're just going to add hydrogen to a system or to a compound. Okay, so over here you see the ketone. The ketone has some electrons on the oxygen, right? What we will do in the protonation step is to abstract a proton from the acid, right? The oxygen abstracts a proton from the acid. The bond between the hydrogen and the oxygen get thrown into the oxygen. Why? Because the oxygen has a plus sign on it. Anytime you see a plus sign, it simply means that the oxygen has an empty space or empty orbital for electrons to sit in there. Okay, so once you do that, this is what you get. The oxygen on the ketone now has a hydrogen attached to the oxygen. Oxygen normally would want to form two bonds. That's why you have a plus sign on this oxygen, because this oxygen has 3 bonds. So it undergoes something we call ketone tautomerization. It's just like resonance, right? So you have this plus sign. What is going to happen is that you can have the double bond on the carbon and oxygen flowing electrons onto the empty space, right? To form something like this. Now you have the plus sign switching from the oxygen atom onto the carbon. Why do you think that is? Because carbon normally want to form 4 bonds, because the valency of carbon is what? 4. But now it has 3 bonds. 1 bond to the oxygen and 2 other single bonds to carbon, right? So this is ketone tautomerization. The second step for the Enol formation is deprotonation. So the first step, protonation, you give hydrogen to a system. The second step is remove the hydrogen, deprotonate the system. So what will happen right here is that we have lone pairs on the oxygen. This is water, by the way, because if you abstract the proton from an acid, you know, the byproduct that you get will be water, right? So the water grabs a proton from this side, and the bond that is shared between the carbon and the hydrogen gets broken off onto the empty space on the carbon, right? Because there's a plus sign on the carbon. That means that there's an empty space for electrons to rent or to come sit in there. Okay, and there you have it. This is the Enol compound. Okay, why is it an Enol? You know, 2 functional group, an alkene plus an alcohol will be Enol. So E from the alkene, Ol from the alcohol, right? So now you have your Enol formed. As I told you earlier, the mechanism has 2 parts. The first part is the Enol formation, right? And the second part of it is the halogenation step.